So we have our section. So if everybody wrote this down, I'm just going to go through this again, and we'll just kind of talk about this. So what this first section says, it says if x equals a is a solution to the polynomial equation of f of x equals 0, then x equals a is a 0 of the function, x minus a is a factor of the function, and a comma 0 is an x-intercept of the function f of x. All right? So ladies and gentlemen, let's kind of get back over to let's go back to dealing an equation that we've talked about before. So let's go and take a look at the problem that we did before. X squared, what was it, minus 8x plus 15, right? And that was just a polynomial, and they just said factor it, right? And that's all we set into there. Now, on your homework for last class period that we did with as far as them set equal to 0, we took that and we said solve it, right? Now, to solve something, though, we had to have it set equal to 0, right? And we still did the same process, but we set it equal to 0 and solved. Now, when solving, we set this equal to 0. Now, the one thing I want you guys to understand, though, is originally of this problem, if I write f of x equals x squared minus 8x plus 15, and I say to solve it, then what we're going to do is we're going to replace 0 with f of x. So that's what they're saying. We're going to set f of x equal to 0. All right? And that's what we did in last night's homework assignment, is they just gave you the equation, though. They just said, hey, here's an equation set equal to 0. Solve for it. But now what I'm going to do is I'm going to give you a polynomial equation, f of x. I'm going to say, hey, what is the solution to it? So you're going to have to take f of x and make it into 0, just like I did right here. Now, we already talked about how to factor this, right? Factor in it. And then you factor this down to x minus 3 times x minus 5 equals 0. And then we have a product. Now, the product, why is having a product, why is factoring so important? Why is having this product? What is this allowing us to do now that we have it set equal to 0? Right? Because remember factoring, when I ask you to factor something, all I'm asking you to do is take x squared minus 8x plus 15. Right? When I say, hey, do this and factor to this, I didn't change the problem. I just rewrote it as a multiplication problem, right? I wrote it as a product. Does anybody know why having the product equal to 0, why is that so helpful? What does that allow us to do? It's a property that you've talked about. Do you know the property? No. Do you know the property? The zero product property, exactly. You guys remember the zero product property states if you have two things multiplied, two numbers or anything multiplied that equals 0, then one of those numbers, a times b, has to equal 0. It doesn't matter if we're talking about numbers, variables, or an expression. If a times b equals 0, then a equals 0 or b equals 0. Right? It doesn't matter. A does not have to be a number. It can be an expression. So ladies and gentlemen, if I have this times this equals 0, then therefore, one of them we're going to set both of them equal to 0. So I say x minus 3 equals 0, or x minus 5 equals 0. And now is it able for me to solve? Yes. All right, so we solve. All right, so now we've solved it, right? We found the solutions. And it says if x equals a is a solution. So what is one of the solutions to that equation that I just gave? What is one of the solutions? X equals 5. And what's another one of the solutions up there that I just did? X equals 3. So now I have two solutions. Does everybody understand? Right? Because what can you do with the solutions? If you know it's a solution, you can plug it back into the equation, and it'll make the equation true. Right? All right. So those are my two solutions. Good stuff. Now, in your notes, the next statement says, if x equals a, oh, I kind of wrote that. All right, so if x equals a is a solution, then x equals a is a 0. So therefore, I can ask, what is 1, 0 of this polynomial equation? I'll say it again. Yeah, x. Hold on. Yeah, a equals, well, correct. If x equals a is a solution, that means if a is a solution. So we already said the two solutions are 3 and 5. So if a is a solution, then x equals a is a 0. So if your 3 is a solution, then it's going to be 0. So could you tell me maybe a 0? What's a 0? X equals 5. Yes, that is a 0. It's a solution. It's a solution to the equation, and it's a 0 of the function. It's the same number, though, right? And the other one is x equals 3. So x equals 3 are solutions to the equation because they make the equation true, and they're zeros to our function. All right? Now, this is where it gets a little exciting. Here it says x minus a is a factor of the polynomial function. So I might say, hey, what are the factors? Now, remember, we did this. Remember the factoring technique. You go from here to here, right? The x equals 0 doesn't matter. Just go from here to here. This times this is your factored form, right? So we say these are your two factors. But what you guys need to know is if I give you a 0, then you can write it as a factored form of x minus a. So notice 3. X minus 3 is the factor. 5. X minus 5 is the factor. So these are my two factors. And does that make sense? Because they're part of my factored form, my polynomial. OK? Kind of, Juliana? OK? All right. And the last one that I want to go over with you guys is a minus 0 is an x-intercept of the function. So you guys, we've talked about quadratics. So you guys should be familiar a little bit with quadratics. Quadratics has x-intercepts. It could have 0 x-intercepts, or it does not exist in the real number system x-intercepts. It can have 1 x-intercept, and it can have 2 x-intercepts, right? All right. So all I want you guys to know that. So therefore, 1 x-intercept would be, what would 1 x-intercept of this problem be? We already know the zeros and the factors. So an x-intercept would be 0 is a part. 0 is going to be for your y coordinate. And what is my a in the problem that I've done? 3. And well, so we have 3 comma 0 and 5 comma 0. That make sense? OK. So that's our one example of the zeros and solutions and factors. You guys need to know the different, not really the difference, but you need to understand how zeros and solutions are related to each other, as well as how they relate to the factors. So now, let's get into some fun stuff. All right. Thank you for that enthusiasm. All right, so I'll have a little fun. In the back, you see x plus 1. X plus 1 raised to the first power means that x plus 1 is being multiplied by itself how many times? 1 time. JD, x plus 1 raised to the second power means x plus 1 is being multiplied by itself how many times? Twice. Don't know your name yet. X plus 1 raised to the third power is going to be multiplied by itself how many times? 3 times, right? Now, the only difference out of this is you guys are seeing that there's a little bit of change, but what in that expression, what is actually that's being changed? What's that? What do we call what that number that's being changed? What do we call it? What do we call this little number raised up here? The degree, your exponent. If we were going to polynomial, you could look at a degree. But you could say this is just going to be the exponent of this expression. All right, it's the raised power of this expression. So we obviously know that this exponent is affecting how many times we're going to multiply something by each other, right? OK. So now what I want to do is let's go back through. And what about if I have, let's go and talk about, now we know our factors come in this form, right? Now I did x plus, but remember, this could also be written as x minus a negative 1. Yes? X plus 1 could be rewritten as x minus, because factors come in the form of x minus a. They always come in the form of x minus a. But you understand that x plus 1 is really x minus a negative 1. It's the same type of thing. So what we're going to do is we're going to talk about these exponents. And I don't like that marker. So x minus a k. All right? So write that down. We're going to get some very special important stuff here. All right. Now, obviously, ladies and gentlemen, we're talking about polynomials. Polynomials, we cannot have a variable in the denominator. And remember when you had a negative exponent, that means it goes in the denominator, right? When you had a negative exponent in the numerator, you put in the denominator. All right. So k has to be greater than 1. All right. And when k is greater than 1, what we have is a repeated 0 with multiplicity of k. And okay. Now, when we talked about when we're going to be looking at this, all I want you guys to care about, kind of like leading coefficient test. Remember leading coefficient test, all we cared about the degree, even or odd, right? Even or odd. That's all we're really going to care about this multiplicity. If k is odd, all right, and then for k is odd, the graph, okay. Just want to make sure I have the right language. The graph crosses at the x-intercept right? Now, could I have written a comma 0 as well? Yes, it's the same thing, right? This is just your solution. This is your 0. But remember, you could also write it as your x-intercept a comma 0. So if k is odd, the graph crosses at the x-intercept. Now, if k is even, the graph touches at the x-intercept, x equals a. So if k is odd, the graph crosses at the x-intercept, a equals 0. And if k is even, the graph touches at the x-intercept, x equals a. I might say, what? X-intercept, I thought that's where it always crosses, right? Isn't that what we always talked about a lot of times when you guys first learn x, y intercepts, where the graph crosses, all right? But now, you guys should be familiar with this. What about this? Y equals x squared, right? That should have been the first quadratic you guys learned how to graph. That looks like this. Does my graph cross at the x-intercept? No. It literally touches it and rebounds, right? OK? Now you might say, well, how is this? Where's like this in x minus 4? Now this can kind of get a little tricky to you. But 5 minus 0 equals what? Anybody, you can just shout out 5. Thank you. So I could write this as x minus 0, right? And now, is this in a factored form? Yes. What is my k? 2, which means it's even, which tells you that the graph is going to touch at that x-intercept. OK? So ladies and gentlemen, this is what we're going to be calling our multiplicity. So what we're going to be doing today in your work is we're not just going to be factoring, but what we're going to do is we're going to be solving to find the zeros. We're going to solve, find the zeros, and then once you find the zeros, we're going to go back and look at the factors, right? So once you know what a 0 is, we can write it back, we can check on our factors. We're going to take a look at our factors, not our zeros. This is very important. We're going to take a look at our factors and determine what our k is, which is our multiplicity. By determining our multiplicity, we'll be able to determine, does our graph touch or cross the x-intercept? OK? So what I'm going to need for you guys to do, because we're going to do some example problems together, I need you, I know your desks are all in group 3. That was from our testing that we did today. So let's see, I have 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Perfect. What I'll have you guys do is, why don't you guys just turn your desk, become it together, become a group of 6. You guys can just turn around and become a group of 6. I'll have you guys become a group of 6. You guys be a group of 6. And then if you guys will bring your desks over here, you guys can become a group of 6. OK? On your mark, get set, go.